Well, good morning. Glad to see everybody sheltered in place. I would like to have you go to structurlam.com if you haven't already downloaded our guide, and we'll get started here in another 30 seconds. So grab it and we'll be right back. Okay, here we go. We got the Structurlam U.S. Mass Timber Technical Guide, and today's webinar topic is going to be the design process. And I want to welcome you. This is Chris Spickler. If you've been on our other seminars, you know who I am, and we'll meet the rest of the team here in a minute. But I think what we'll do first is kind of talk about rules of engagement. Okay, here we go. So we're going to go ahead and allow you to ask some questions through this whole presentation. You can hit the Q&A function, bottom of the screen, and that's going to allow you to type in a question. And yeah, we may take a few during the presentation. I think it makes sense. We may make up our own, I don't know. But at the end, we'll give you 10 to 15 minutes. We'll go through all your questions for you, okay? And then if you want, you can also send us a question, or you need information at zoom@structurlam.com. So where's the rest of our hosts? Well, let's see here. We've got Chris Spickler, right? I manage the Southwest region for Structurlam. I'm located here in Sacramento, California, but make no mistake, I was born and raised in Fresno, California. Go Bulldogs, Fresno State graduate. Yeah, I did get an engineering degree. I did get a California license. I did do engineering. And I found out that I really enjoyed kind of more teaching and coaching. And that's why I got into working for Structurlam and working with mass timber and being able to go out in the industry and consult with those in the Southwest region. But we've got Elise. And Elise is in the Pacific Northwest region. Good morning, Elise.
Good morning, Chris. Hi. So I am based in Portland, Oregon, covering the Pacific Northwest. I graduated from Cal Poly San Luis Obispo with a major in architectural engineering and a minor in sustainable environments. And then I went on to work for just under 5 years as a design engineer, and then for APA for about 2 years. And I have now been with Structurlam for about 1.5 years.
Oh, man. So we're going to give you all the code APA questions, right? Maybe not. Corey, why don't we give you the code question? Corey, tell us about yourself.
Yeah, so I graduated in 2013 from the University of Oklahoma, did 3 years of design work for a steel manufacturer, and then I kind of saw the light and wanted to move to California. So I started working for Structurlam in 2016. And then actually relocated out here to Dallas, Texas in 2018.
Wow, living the mass timber dream. I love it. Good job, team. So here's where we operate. You can see you got the kind of a North American map, Canada and the US. And I do understand that probably half of you on this call are from Canada. Welcome. I understand too that it's not morning on the East Coast, so good afternoon. Sorry. But I'm going to tell you that this is a U.S. design methodology. We're going to work through some of these things. There's going to be a few things different on the Canadians' design, and we might bring up those differences here and there for you. But right now, you look at the stars on the map. That's Elise in Portland, Chris in Sacramento, Corey in Dallas. But Corey, what are those pins on the map for?
Yeah, Chris, those are our manufacturing facilities. So currently we have the red or green pin up there in British Columbia going. That's going to be Penticton. We're going to do Douglas fir glulam and SPF and Douglas fir CLT. And then the blue dot down there in Arkansas, that is going to be our new plant in Conway that'll be using Southern Yellow Pine glulam and CLT. Actually have a 12x60 press, so we'll actually get bigger panels out of that facility, and we're looking at probably a 7 to 10% reduction in our cost to those southern markets.
Whoa, so when is that operational?
July 2021.
Okay, get your orders in. We're taking orders for Conway right now. But today's topic is going to be, what's the process in putting together a system design? So we're going to talk through some of that. We're going to talk through the pages from this guide. And so you'll see at the top of each one of the slides, there's going to be a page so you can follow along and see what's in there. So we'll work through that. But the guide itself actually is put together in a sequential order. Right, Elise?
That's correct. Yeah. So it starts out fairly generalized, talking about mass timber systems and the benefits when compared with other options. And then also the Structurlam advantage and what Structurlam in particular can bring to the table as a partner. But the focus of today's presentation is shown in bold and underlined here, where we're going to walk through the mass timber design process, walk through the steps that we'd recommend as you consider a mass timber system and the key elements that you should factor into your design, and then also take a look at the product design properties and load tables as you look more specifically at exactly which panel thicknesses and layouts would work best for your design.
Good, perfect. That's what we wanted. And let's talk about a couple of things that are important to know. And I think one of those things is code acceptance, which is a start. And then the second thing is quality assurance. We bring these up because this is what our design guide's based on. So we wanted to make sure that you had that. And we want to talk even an expanded version of the North American Code Acceptance. Corey, I think I tagged you for this one.
Yeah, so right now, CLT is recognized in the 2015 IBC. So that's going to really affect the NDS and the ANSI standards for CLT and Glulam, the PRG 320 and A190.1. And really all of these North American codes are based off fire-based performance, not structural-based performance. So we're not going to have members flash over, and the adhesive actually lets that drop off into the fire and create more fuel. And then what's coming is the 2021 code changes. So we're kind of tying that in with our plan, I think, right, Chris?
Yeah.
And so we actually on page 10 have a little bit more expanded on this topic, but just what you need to know is type 4 construction is going to be broken into 4 new building types. We're going to have type 4 heavy timber that we've always had, and types 4 A, B, and C that are going to be 18, 12, and 9 stories. And we'll get into the different fire ratings for each one of those, I think, in a little bit. But one other thing we need to address is all of these codes really only address the vertical applications of CLT. And so when you're wanting to use them in a lateral diaphragm, or maybe even a shear wall if you're in a low wind seismic zone like Texas, you're going to need an ICC report that has values in it. And then we actually took that a step further and got those values put in for an LARR. So we've actually used CLT as a diaphragm in LA.
Wow. I think out of all that, that's good. And I know, Corey, you got us that LA City R. You worked down there with LA City to get that. So I think you're probably the most knowledgeable. I think the biggest thing for me is the changes in the 2021 IBC. Most of you on the call are aware of that. I think a catalyst for that and validated it was our Brock Commons 18 story in Vancouver, BC. But also know that there are states in the United States that have adopted the 2021 already, right? I think you've got Oregon, Washington, and there have more states coming on board to try to pull that in early. I think those urban infills want to be able to see that mid-rise 12-story or even maybe go to 18. So thank you, Corey. But quality assurance, yes, APA background in your blood, Elise, maybe walk us through this.
Sure, Chris. So Structurlam is PRG 320 certified. So that means that we have the design property compatibility based on a native wood species. We undergo the fire performance testing, which Corey just touched on, and we'll get to in a little bit more detail on. And then we also go through glue bond durability testing. So we verified the durability of our face bond adhesives through ongoing cyclic delamination tests. And then we also have quality assurance through our own QA/QC process, and in addition, an independent third-party auditor who comes to our plant twice monthly and inspects our manufacturing operations and also verifies our compliance with technical criteria. And more information specific to Structurlam's Crosslam product is shown in our product report, which is shown here. It's PRL 314, and that provides more information about our Crosslam product and its conformance with codes and standards.
Good, great summary. So now that we've got the basis set for what we're about to do, let's talk about what we're going to learn today, right? Well, we kind of broke it into 5 steps. You're going to see it right there on page 23, or maybe that's page 24, might be page 24. Anyway, step 1, you want to determine your grid pattern, and each building, where it's located, the occupancy, the heights, that's going to dictate that. So we'll talk about that. Then you're going to want to pick your mass timber system that fits that grid, and then look at the design considerations: fire, sound, vibration. Remember, this is a system approach, and that becomes part of the system. It's not just about engineering structure, design. I mean, I'd like to think that that's what I'm good at, but all these other things come into play that make that design happen. So determine the preliminary member sizing, and then maybe talk a little bit about preliminary budgeting. I mean, I think all of us realize that you can go through and pick the structural system, add and make sure that it works for fire and sound and acoustics and fits the building, but it's got to fit the budget. It's got to fit the budget, and we want to make that happen. We want to make sure that that project, if you choose mass timber, it's competitive. It's competitive against concrete, yes, and it's competitive against steel. I mean, there may be pre-manufactured steel buildings that come out to site that it's just a completely different apples to oranges, and it's not going to get you down into that price range. So we want to know where it fits. We want to give you a chance to be able to come up with the most value-added economical system. So that's what we're going to do, and we're going to kick it off with step 1. And step 1, Corey? That was my intro to you, Corey.
Yeah, so when you're determining your grid, obviously that's going to be different depending on which type of building you have. Offices, you're probably going to be, larger 20 by 20, 30 by 30 grids, where if you're doing a higher or mid-rise multifamily, you might be, smaller 15 by 20, something like that. Or you might be doing even a hybrid system where you're not really looking at, per se, a grid, but what's your panel going to span in this hybrid system, or, steel purlin to steel purlin. So I think really when you're doing all this, though, you need to be thinking of the panel widths that we make. So our panels come in 7, 10.5, and 9, 10.5 widths. And if you really want to drive the cost down on the project, you're going to optimize those grids to lay out with those widths. And then in the length, we have a little bit more flexibility in how we optimize. So we're usually not having a huge amount of waste because we didn't optimize correctly for the length direction, but width can really drive the price up.
Yeah, very good. You're right. Absolutely. And the size of the building, the number of stories, where it's located, is it wind, is it seismic, yada, yada, yada. But let's talk about selecting the system now. Let's say you've got a grid and now you want to select the system. So we're going to do kind of an all-encompassing on a few projects with a few systems that we've seen kind of resonate throughout the industry. We've done 450 mass timber projects with cross-laminated timber in North America. I think about 140 in the US. That may come to a surprise to you. But those of you from the US on the call, shoot me a note and I'll send you the projects that are in your market that we've already done. And maybe if you want to go look at them, you can. But right now we're going to talk about the post and panel, and then we're going to talk about the post beam and panel, then a hybrid light frame system, and then we're going to introduce the mass timber system selection chart. So that's a sequence we're going to go in. Very similar to what we had in our last presentation, where we introduced them, but we didn't really drill down and talk about them that much. So now that's what we're going to do. We're going to drill down and talk about them. So for this option 1, post and panel system, let's see. Elise, how about you?
Yeah, so for the post and panel system, for those who aren't already familiar with this system, it is similar to the Brock Commons project, which is the dormitory building, 18 stories at the University of British Columbia campus in Vancouver, BC. And for this system, we are spanning the CLT panels directly over the glulam columns. So the panels are spanning in 2 directions. that eliminates the need for beams. And so that can help to maximize the floor to floor height. And there is a little bit of limitations in the grid layout though. Yeah, thanks, Chris. So as you can see here, the grid spacing in the Y direction is limited to between 8 and 10 feet max, and then in the X direction about 10 to 14 feet. Where those limitations come in is because of the panel width. So as Corey mentioned, we're at 7 feet 10.5 inches or 9 feet 10.5 inches for our panel width. So that's what dictates the 8 to 10 foot max width of the grid spacing. And then the length of the grid spacing is limited because we are relying on the strength of the panels in 2 directions. So a combination of the strong axis and weak axis. So that sort of limits the allowable span that the panels can go. But the benefits of this system, it creates a lot of open and clear head heights. So again, we're eliminating those beams, which can maximize the floor to floor heights. And then also can help to ease the MEP routing and ducting so that you don't have to, again, worry about those beams getting in the way of those utility lines. And so when you're looking at this system, again, you would probably be looking to a similar type of project as Brock Commons, so the dormitory style projects, multifamily residential, even some apartment projects where you can really work within that tight grid spacing for your floor plan.
Yeah,
and
that makes sense. Good
yeah.
job.
And when you're looking at fire also, Chris, one thing just to remember is that
yeah, talk about fire.
Yeah, so for the Brock Commons, we went up to 18 stories for that project. And so this entire mass timber system was fully encapsulated with sheetrock. And so if you're going to that project today, you would never know that it's a mass timber project. But that's how they addressed fire for this one. So getting up to that 18-story height limit, which ended up becoming sort of a basis for the Type 4A construction coming up in 2021. And so that's one way that they addressed fire for this type of project.
That's great. And for those of you out there in the audience, yes, I control the screen. So Elise has to prompt me once in a while to change the screen, but that's okay. I'm good with it. I can handle it. But Elise, a little bit on the MEP. I know on Brock Commons that they poured some lightweight concrete over the top of the floor. And of course, it was all encapsulated. So they sheetrocked the ceiling. And I know sometimes we get into these projects and the interest is, I love the look of the material. I want to expose it. So we expose the ceiling. Now we're kind of stuck on what we can put in there. And so maybe as we go through these, we'll talk about some others. But I know on Brock Commons that they did run some of the utility through the concrete deck, but also through the walls. And the system for the walls was actually conventional steel studs between the columns so that they create a wide open space between the party wall, which was a dual set of steel studs. So there was a way of getting the MEP actually through the walls and through a drop ceiling in an area or in the hallway. And so we kind of want to share that with you for the Brock Commons, but certainly this system can be used in 4 or 5 stories as well. It doesn't have to be 18. So did I miss anything?
I think you got it.
Good. Okay. So option 2, post, beam, and panel system. And there's kind of 2 versions of this. And Corey, I think you're the best one to talk about this.
Yeah, thanks, Chris. So I think right now the best way to look at this is 2 different projects. So we have Carbon 12 on the left and First Tech on the right. We'll talk about First Tech to start out with. So First Tech is using the post beam and panel without subframing. So what we're going to do is run the panels perpendicular to the girders. We're going to have probably more rectangular framing or grid layout, sorry. So we're going to span the panels probably somewhere in the 15 feet max range in the one direction, and then you're probably going to have your primary girder in around 30 feet, so probably, in the 15 by 30 range. This reduces the amount of pieces that we have. Reduces the volume of lumber we have, so this can really drive the cost down for both. Then on the other system where we are adding the subframing back, we're probably going to have a more open grid, trying to get maybe closer to 20 by 20, maybe even as much as 30 by 30. We're adding those subframing members so that we can use a 3-ply panel usually. Really the name of the game is to have the thinnest panel possible. And I think that usually you start adding subframing once you have 20 feet as the grid in both directions. So if you have a 20 by 20 minimum, you're probably going to go with this over the other system where you're going to use the or remove the subframing. And then kind of, touching on fire, I know on First Tech, that was a type 3A project. So they actually used a char calculation to get their fire rating on that one. And I believe on carbon 12, that would have been a type 4C. I think that was kind of the basis for type 4C, wasn't it, Chris?
It was part of it, yeah.
And so that one as well would have used the char calculation, but would have been able to push the height limits. And then acoustically, I know that First Tech used the elevated floor system. Chris, what did they do on carbon 12?
Yeah. First Tech had that raised access floor, so they could run all that mechanical and electrical and everything through the floor, so they didn't have anything exposed underneath except for the sprinkler mains. But on carbon 12, as you can see on the left there, that picture that I'm showing right now, you can see there was some furred out areas that allowed them to put in some of their mechanical to be able to air condition the room or put it over the kitchen if they have to, ventilate that. So they did expose the ceiling. And so for those of you that don't know, carbon 12 is a 8-story in Portland, and Path Architecture and Kaiser Group that developed this project. It was the first to go 8 stories, and it is the tallest CLT building in the US right now. But you can see what they did by exposing it. They then had concrete, and they ran some of the electrical into the concrete slab that was poured on top, and then daylighted it underneath. And it gives you that beautiful open look to it. And as Corey mentioned, it was a type 3A. So as far as was type 4C, but 3A at that time, because this was 3 or 4 years ago when they didn't have those out yet. And the 3A required a 1-hour rating. And so you can see, even with the timbers, with the hidden connections, the connections are insulated by the wood and the panel itself. A char calculation was done. And Corey, we're going to talk about that later, so I won't go into that anymore. Let's see, did we capture everything we wanted to on these 2 buildings, Corey?
I think so.
Okay, all right. I'll just mention that we see these buildings in a 20 by 20 grid to a 30 by 30 grid economically done. The 20 by 20 can be done with just the post beam and panel, but you're going to have to add that subframing, like Corey mentioned, to get you your 30 by 30 grid. But you can still get into a 3-ply panel, just over 4 inches thick to economize the deck throughout the whole project, which allows us to come up with our best system for that value. Moving right along. Okay, hybrid light frame system. Okay, so when we think of hybrids, we think of there's a couple of types of hybrids. This hybrid is that we're using a conventional framed wall, could be framed out of studs made with wood or steel, and we typically see it framed in a factory. So it's factory built, sent to site, pick and place, that allows you to compress the schedule. Now at Structurlam, we understand the system, we complement the system with a CLT deck. The way that you can also pick and place even up to a 10 by 40 CLT deck, 400 square feet every 15 minutes. Do the math, 25 to 30 panels a day, you're going 10 to 12,000 square feet a day of deck being rolled out. So that's an efficient, that's a fast system. But if we're going to use this system, there's a couple of things that we really need to do. We need to economize it. We want to be able to get that deck typically to a 3-ply panel, just over 4-inch thick panel. And we do that by trying to coach those that are putting these together and putting in the wall layouts at maybe a 12-foot max, 12.5-foot max. We can then take a panel and do 3 of those spans with a 40-foot panel, and we can capture the system to be able to perform for vibration, for the structural values, but also you want to be able to get that system to work for fire, acoustics, and being able to put in your mechanical. So what you're looking at here, I went back to that earlier slide. This project here is Adera, their development. It was Virtuoso. And that project, actually, I know you're not going to believe this, but they didn't expose the ceiling underneath in the units. They did expose it on the balconies and in some of the roof areas. And so when you look up at the project from outside, you're going to see lots of the CLT in some of those areas exposed, and it looks beautiful. But in the actual units, I know this is blasphemy, but they dropped in a ceiling, an 8-inch cavity, filled it full of insulation, and were able to run their electrical plumbing. And anyways, that cavity accomplished 2 things. One, it allowed them to take care of the acoustic layers below instead of above. I mean, there's a combination of it, but when they were all said and done, they achieved in the low 60s of an IIC and STC. So that unit, which they had put into a kind of an upper scale multifamily, they wanted to be able to market it as the quiet home, and they did. And they moved all those units rather quickly because it resonated with people that be able to use a renewable resource, be able to get a quiet home and get a solid floor. So vibration, sound, fire, all of that was accomplished in that system on this project. Yes, you can expose the ceilings. You don't have to put the drop ceiling in there below. You can just put in a drop ceiling at the entry to the units, like a bit like they did on Carbon 12. And then you can go ahead and put your acoustic layers above. And we'll talk about some of those acoustic layers in just a minute. So that was kind of my summary. Elise, Corey, what did I miss? Nothing.
Got it all, Chris. Yeah.
Nothing. Okay. I'm sure I missed something, but anyways, let's march right along. So now, system selection chart summary. So we want to go through and kind of give you a view of our kind of best practices for the different units. Let me just say that I think that the drive that we have is to allow the system selection chart to pick for your occupancy, for your grid, for your location, the best system. But remember, economizing that system and considering all the aspects of a system design, it may in some cases give you a thicker panel because you save money in insulation or concrete on top, or but I think the net value of that system is what we want to drive towards. And our best chance of getting there is we try to drive the economics of the system down. So Corey, I want you to be able to go through and take us through this table. I know they're a bit hard to see. We've got them on pages 38 and 39, but walk us through this.
Yeah, sorry, I was on mute. Looking through these, so we've already kind of covered post beam and panel and post and panel. I really would maybe, before we dive into everything, draw everyone down to the steel CLT hybrid. That's something I've seen become very popular in Southern California and like the South Central market, really popular in Texas, especially because, these office structures, it's kind of the low entry point to CLT. You still get to keep your big 40 by 45 grid or whatever works best for your office furniture. And you're really just trading out that B deck for the CLT on top. And you don't have to shore it now, which is usually a pretty easy sell for the whole project team. But kind of looking at...
That's good. I might just tag on to the next one if I'm okay with jumping in here, Corey. I know that you know, the post and panel obviously was Rock Commons, and the post beam and panel maybe First Tech, and then post beam purlin panel maybe Carbon 12. And then of course the Virtuoso for that hybrid system. And then that other hybrid Corey talked about is 901 East 6th Street in Austin, Texas. Corey, you know that project well, office building that we did about 5 years ago. And we're seeing more of that. But then there's that last one, that CLT tilt up. And I don't think we talk about that a lot. But I do know that we've done a number of these. We did a fitness center in Spokane, Washington that turned out beautiful. We've even designed and got it in for permit for a large box store in Porterville, California, where we actually replaced concrete masonry units around the perimeter of this very large box store with tilt-up CLT crossland panels. And the savings in that was taking what was 3 months to put up the CMU, to putting it down around 4 weeks to pick and place all these panels around the perimeter. Also notable about that, along with 3 or 4 other projects in California specifically, is using it as a shear wall. Oh yes, now I've gone off the reservation here. I'm talking about shear walls. What we did, we have about 4 precedence projects for shear walls in California, and that was one of them. So there is I think another market out there waiting to explode, whether it's going to be industrial, warehouse, or box stores, where you can put up CLT panels as tilt-up walls, even during the winter when the ground's frozen, when you can't pour or you can't get the masonry to cure. So Corey, I stole your thunder. I jumped in on that, but maybe give us the rest of this chart, because all across the top, you talk about every aspect of the system.
Yeah, so I think the way the chart is really set up is you're going to pick your typical occupancy and use that to maybe narrow down which system you're going to use. It does show you, how many floors you can do. Now, the stories have kind of been adjusted, assuming what's coming in the 2021 code. You'll see your CLT spans, your typical grids. One thing I do want to note, we do show the fire resistance for these, but that's I would say more what they're capable of. We'll get into this in the fire part, but all of these systems, depending on what occupants they are, could require 0 fire rating, which is a really big cost savings for the project. And then after that, I think just kind of following up, we get into a little bit of acoustics, and then the value proposition for the system over the others, and why you maybe would go with that one.
Yeah, there's a lot here on these charts, and it goes through every aspect of trying to validate the system you've picked. But I think, as we talked earlier, there are critical considerations for design. It's just not about the panel. And so let's kind of walk through, well, how about connections? Sure. How about fire performance, acoustics, vibration? I want to just say right now, we're going to touch on all of these. These, each one would take a separate webinar to really spend the time that we need to. I mean, I think as professionals, all of us are willing to consult with you on each one of these, and happy to do that. But we're going to touch on them. And I guess maybe, Elise, maybe you want to start with connections.
Yeah. So I'll just quickly highlight some different connection types that are worth considering as you're looking at a CLT project. And some of them are shown here on the screen. One of the main connection types that's really important to consider, and some of the advantages and disadvantages of different options, is the spline connection, or like the adjacent panel connection. We show here the plywood spline. There's also a butt joint connection, half lap. There are a few different ways to address the panel to panel connections. I probably most often see the plywood spline, and this option has a few advantages. One being that the plywood spline can be designed to transfer horizontal shear, so the CLT system can be part of your horizontal diaphragm. And even using nails, you can design that spline to transfer the horizontal shear from panel to panel to create a full, horizontal shear system. When you're looking at there's also like the half lap, which can also be designed. There's a little bit of waste that's inherent in the half lap connection, but that's also a great one too. And then again, the butt joint connection where you're just screwing the adjacent panels together. When you're looking at the glulam connections, there are a few different types to consider here as well. Custom steel connections, but then also proprietary systems. And so here we show the hidden connectors. Ricons or Megants are a common type of these connectors. They are concealed within the glulam beam and column. And so they are pre-assembled in our factory and shipped out to site ready for assembly. And since they are concealed, they can work with the fire rating requirements. So working within that char calculation to be fully encapsulated and meet the fire rating requirements of the building.
Whoa, fire. I hear Corey's name. I think, Corey, didn't you say, Chris, I've got to do the fire performance section?
I don't know if I said it like that, but I think I agreed to it. You know, there's a few different ways you can handle fire. You can do testing of the panels, but you can also do, God forbid, cover it with sheetrock. But definitely the most popular way to go about it is the char method that's in chapter 16 of the NDS. There's actually a formula there at the bottom of the screen. Really, it works out to where about every hour of fire rating you need, you're going to add about 1.8 inches of material and do exit loading calculation with the reduced section. That's all based in the stuff in chapter 16. You actually get a pretty big allowable load increase for that specific condition. But maybe taking it over to the table on the right, this is table 601 out of the IBC. And this is really where I think you can target some very large savings. Specifically, you know, we've kind of dug into which buildings were which types, but you know, type 4A, I think that's where I see a lot of projects that might be able to be type 3B, and they go with the type 3A, and they're having this extra hour of fire rating required to the primary structure, which could add, you know, maybe 10 to 15% to their mass timber package. Also, you know, especially the type 4 heavy timber, the traditional way we do it, you're actually using code minimum prescriptive sizes that are actually pretty cost effective for those structures. Now, there are some different stipulations to why it hasn't become as popular with like concealed space, but you know, really is considering your building type pretty thoroughly when you're going to go down the mass timber path to make sure you're getting the optimal building classification type so that you don't have a huge fire rating you maybe could have avoided.
Yeah, that's right. You know, I want to just explain that, you know, if you're looking at this, you're going, oh, you mean I got to add 1.8 inches to my mass timber thickness, my CLT thickness, maybe a glulam. I've got to, so you're looking at that, and you're saying, oh my gosh, that makes the building so much more expensive. Well, hold on. I think if you really break down this calculation, and I know there's some online calculators to do this, but really that equation down there is actually pretty simple. And when you do take away that 1.8 inches, what's left, remember, that's going to be short-term loading. That's going to be maximum design value for what's left, and you're going to just want to get it for exit loading. So you really don't have all the loading factors in there. You're being able to take the maximum value for what's left. We have even seen in a 3-ply panel that the top layer alone actually can span the distance once you take that 1.8 inches away. So don't think that, well, I'm going to go 2 hours, so I needed a 5-ply panel. Now I'm going to have to add a 9-ply panel. No, that's not true. And you need to be able to go through those chart calculations. We see that as probably the easiest way to get your values. And the type 4 A, B, and C are also generated by that with a combination of number of sheetrock covered material, and then what's left, taking maybe the 1 hour for a total of 3 hours. So you can add those up, and that's probably another whole presentation. So maybe I should move on.
Maybe 2 more tags for maybe perspective. You know, you're mentioning the 3-ply and the 2 hour. I believe we got a 1 hour rating out of a 3-ply system at office loading at 10 foot on center. And I believe we have a E119 fire test for a 2.5 hour rating on a 5-ply up to 16 feet. So you can definitely get some pretty reasonable spans out of a 3 and 5-ply under these fire conditions.
So as a recap, type of construction, type 4, A, B, and C, or type 4, prescriptive, gives you the values. Char method in the chapter 16 NDS, just calculate what you need, see if it works. And then 3, testing. Those are the 3 major methods for getting your fire performance. So enough, stop. Okay, I will. Moving on, acoustics. Who wants to take acoustics?
I think I drew the short straw on this one.
Oh, did you? Nice.
So yeah, starting out, we got a table on page 56 of the new design guide that I believe we borrowed from FP Innovations. This is looking at a 5-ply panel. We're looking at a couple of different acoustic options, but really, maybe zooming out, typically you're going to see a CLT panel with maybe 1 or 2 layers of Acoustimat and a topping slab, or you're going to see the CLT panel with that elevated, that raised access flooring system, similar to First Tech. One thing I will say is I've actually seen projects where they're using a 3-ply and they've designed it for that. And then they get into acoustic solutions and they're having to add 2 layers of this expensive Acoustimat. And they just say, man, I'll just use a little bit thicker CLT to get the code minimum and just use 1 layer of Acoustimat. So definitely kind of looking at the total assembly approach is really important, because sometimes you might be able to bump up other materials like the CLT to drive down the cost of others.
Yeah, and this is just a short glimpse into why acoustic performance is important to consider in your system. And we can work through all the systems, but you may need a code consultant for acoustics. We're happy to point you in the right direction and talk about what's important, because there's way more to it than just STC and IC. But along with mass timber systems, because of the very, very tight tolerances, they can be built with peel and stick membranes that allow you to really seal off units and keep sound from vibrating through the unit. So enough on that. We're running along on time here. Might have to play catch up here, Elise. I think you're on vibration.
Yeah, I'll keep it pretty short and sweet with vibration. I think when you're looking at vibration, there's a couple main points to consider. And that one of the most important things to remember is that when you're looking at vibration, it's either code minimum or code plus. So through vibration design, we're going above the code to give a sturdy feeling floor. And, we're really getting up into like the concrete feel of a structure where we're using thin wood floor plates, but we have a really sturdy and like solid feeling floor. So in our guide, we chose to go by a more conservative approach that is based on the equation that's shown here, which was derived from the US CLT handbook. And this equation calculates effective stiffness based on member properties and span. And for most projects, this will be sufficient, where you can use this simplified approach to determine the vibration performance. In other structures that need to go more in depth into the design of vibration, the industry is going deeper into evaluate not only the frequency of the floor panel itself, but in the entire support structure to measure the vibration of the entire floor system.
Yes,
so if you could go to the next slide, please.
I might just say for you,
Oh, yeah.
Canadians in the audience, you're maybe thinking to yourselves, we've got vibration in our code. Yes, you do. You're way ahead of us, but we're coming up with it, okay? All right.
Yeah, so this is our CLT design table, taken out a snapshot taken from our guide, in which it shows various CLT thicknesses and spans for different floor live load conditions. And I just wanted to quickly highlight the idea of code plus and code minimum and how it's specific to this guide in particular. So you can see in the snapshot that was expanded for the residential loading, we have shown a snapshot of our 3-ply panels and code minimum, which is the deflection criteria, versus code plus, which is vibration. And so you can see in this example, the vibration span governs, and that's what's shown bolded to show like that's your span that you would need if you're meeting that vibration calculation. As you can see here, if you're meeting code minimum, the 87V panel would span just over 12 feet, versus if you're designing for vibration, we're at just about 10.5 feet of total span. So that's kind of the comparison between the two systems and vibration and deflection. But sort of zooming back out to this span table in general. So we show all of our different panel thicknesses and then various floor live load conditions, starting from 40 PSF for residential all the way up to 150 pounds per square feet for library conditions. And so we're really just breaking it down into how far can each panel span under these various loading conditions, and then depending on the panel thicknesses. And then it's broken out even further to specify single span conditions versus double span conditions. So in single spans, we're supporting on 2 supports, just spanning the panel over 1 bay. And then for double span, we're going 2 bays or 3 supports, and taking advantage of that more efficient layout to show that we can span a little bit further with the same thickness of panel. And you can see at the bottom of the double span conditions, a lot of our panels can go above 20 feet and spanning with this double span layout, but that maximum length of 20 feet is limited by the maximum panel length of 40 feet.
Wow, right now I know that chat function's going crazy with all kinds of questions, and they want to know what each one of those numbered notes means and all, and we can walk through that with you on the next round. But let's talk about Glulam Plus. Corey, I think you've got this one to talk about the sizes, what we make, and the values for engineering.
Yeah, I'll try and make this brief so we can get to the Q&A part. So yeah, this is a chart that we have in our design guide to help you kind of keep track of the difference between the industrial sizes and the architectural sizes as far as width goes for our Glulam. So whenever we do that sanding on the beam for the architectural grade finish, we take a little bit of that width off. Another thing to note is that we actually do staggered multiple piece laminations, which can change some of the widths a little bit as well. Let's just go on to the next one, Chris. I'm trying to get to the
You're trying to roll. Okay.
Yeah, we got 10 minutes left. So so this is some design values for our Glulam beams. We actually we have these charts that go up all the way to 20 inches wide to give you just some properties to use. So yeah, if there's anyone that wants to maybe do a deeper dive on what we make, we're happy to answer some questions on that or take the.
I'm sure we will. I'm sure we will. So hey, we made it. We're to slide 29. We're talking about budgeting.
I think that's me too.
I think it is. I think you're the budget king. No, Michael Kaskak is. But you go ahead.
Yeah. So once we've kind of gone through this whole process, we'll put together a budget for you. Make sure that you understand everything that's included. You know, we want to approach this like we're sending you a complete system package. And then most importantly, if it doesn't meet your budget, we need to go through steps 1 through 4 again to find a solution that does. So I think that's the big thing is some people are like, well, okay, you know, the project that had 20-foot cantilevers all the way around was too expensive. It's like, okay, well, maybe we look at one with no cantilevers, stuff like that, you know, going back through, and we're happy to provide, you know, some value engineered ideas to go down just and trying to respect the architectural intent at the same time. It's kind of a fine line to walk, but I think we do it pretty well.
Very good. So, so mass timber design process summary. I got to do the summary here, and I could read through all of these, and we've walked you through all 5 steps and ended up down at budgeting here. But I think what we really want to drive through that prefabrication, and being able to 3D model and then clash detection, bring all the components of the building together to find out how are we building this. Does some plumbing pipe hit something else? We want to go through and kind of vet all that. So it's in that BIM process that if you have a BIM specialist in your team, that you can kind of meet what the promises of the future, which I believe is we want to be on time and on budget, right? Instead of trying to fab it in the field, we want to move everything into the shop and fab it. But along with that comes this, building information modeling, and where we all work together as a team to do that. So we can build it in our computers, then build it in the shop. And then when it gets out to site, we know how many days it's going to take to go up, and we know the cost because we've got it down to the screw in that package. There's no waste on site. So I think that is kind of my last, promise, is that if we can get on board and help you with this process up front, and if you have a BIM specialist, that's the future of the industry, and that's where we want to take you with this. So any last thoughts, Corey or Elise?
I don't think so, but we did have a couple questions come in already. So just a reminder to everybody, there's a Q&A box on your Zoom screen. You can click on there and submit a question to us. We've already had a few come in. So relating to the post and panel grid system, somebody asked if that was similar to a flat slab system, like a concrete flat slab system. And I would say yes, if you're looking at a very generalized comparison where both of those systems are going to be relatively thin floor plates spanning between columns. There's a few differences in how those systems span and are, the design of each of those systems. Oftentimes, like for a concrete flat slab system, you'll have the column capitals at the top of the columns to resist shear, which that is not the way that we do that for the post and panel system. And then also, like, we're spanning the panels from column to column versus obviously the concrete is reinforced. So it's the way that that's working is a little bit different. But essentially, when you're looking at the floor thickness and comparing those different systems, yes, it is relatively similar. There was also a question about a typical hole chart for, I assume it's like drilling holes into the panels and what we would typically see for that.
Yeah, you know what? Of course, I cut my teeth on doing I-joist systems back in the day, and we always had hole charts because we kind of knew predictable the size and where we could put a hole and still make the maximum strength of the joist happen. We have in the industry right now panels being used that aren't in a repetitive action like that, where they can actually calculate that and have a table out for you yet. I know probably Nick Sills is working on something like that, but we do have some rules of thumb that we look at. If it's a 4-inch or less, maybe even up to a 6-inch, that generally that hole can be cut as long as it's not next to other holes. You've got at least twice the amount of material between adjacent holes. But I would default to the engineer of record to be able to take a look and give you that idea of what is the maximum hole that can be cut anywhere. And if you get a larger one, it just needs to go through that approval process. If we're given those up front, we can include it in the model and get it out to the design team to approve, get it back approved, and show that works. I hope that gave you some answer.
Yeah, and actually I think Randy had submitted that question, and he also had another question for us about CLT wall panels and cutting openings. If we do that in the factory or if that's typically done on site. And then he also asked if floor performance can be increased to L over 480 versus L over 240. And with regards to the first question, yes, we do cut openings for windows in the plant. Depending on the size of the openings, we have various milling units that we use, but that's a great way to help reduce the waste on site by doing all of those cuts in the field. And then also usually the cuts are a little bit cleaner when they're done with the CNC machine versus on site. And then floor performance, being L over 480 versus L over 240. Yes, it definitely can be, the floor performance can be designed to whatever the project goals are, and that would be determined by the structural engineer to say, based on which floor performance is required, what the relative, what the required panel thickness would be. Our charts just address the L over 240 condition, but definitely they can be, the panels themselves can be designed to meet whatever floor performance requirements are needed.
Right, you got code minimum and you got code plus. And code plus vibration usually governs, and it's probably well over 480. But this is a preliminary sizing guide. Final calcs still need to be done, and that's when you could apply that.
Right, yeah. We also got a question about what is the best way to protect a slab past the window or wall panels or achieve an inset balcony?
So when that protection, is that protection against moisture, Elise? Is that what I'm understanding? Or?
I think so. That's my assumption as well, maybe. So maybe if you're going exterior, what's the way that you protect those panels against, you know, exterior exposure?
Yeah, and I guess I'm just going to jump out and say, unless Corey, you want to take it, I want to say we do an edge sealer to the edges of our panels. The end grain is where water either leaks out or leaks in. I think that that's true of any wood product. So what's awesome about CLT is that it's cross-laminated, right? And that means that you've got face grain on top of face grain going the other direction, which stabilizes the panel. So the panel in width and length will be within an 1/8 inch for the life of the panel. Awesome. Now, what that also does is it allows the edges to have end grain on all 4 edges. But if we shop apply an edge sealer, that really helps mitigate a lot of that moisture leaking in and out. So that's number one. Number two, yeah, it's easy that as you've got a site, you've got the deck down, you've got the perimeter of the deck, you're now putting up an enclosure system over that. I think it's important that each enclosure system requires a different spacing and a different connection and a different distance from the column that the deck has to go out. So I think we always want to get your enclosure provider on board to solve that early, because that's very important to figure out early. But you can also, for weather protection again, you can put a vapor barrier around the edge, and there's a lot of different peel and stick membranes that you can put on to kind of shield moisture, and happy to help you with that.
Great, thanks, Chris. Yeah, so I think we're kind of getting close to the end of our time here.
Wait a minute. There was one question somebody, I know they asked. They said, in this new NBA format, who's going to win the NBA? And I'm going on Kings, baby. Sacramento Kings, come on.
Not the Trailblazers?
Oh, gosh. Don't bring up the Dallas
Mavericks. Fair weather
Mavericks.
fan, can we, Chris?
No. All right, so did you have one more question, or are we done?
Well, there's a few more questions, which I think we'll, just in the interest of time, we'll wrap it up. But if we didn't get to any of the questions, we can follow up with responses to those individuals who asked those questions. And then also keep a lookout for a survey that will be sent out. We'll ask for your feedback on this presentation, and then also for your input on any future presentations that you'll want to see as well.
And there we have it, the Whirlwind Tour. We finished in an hour. Thank you, everybody, for coming and listening in. And we didn't get your question. We will send it to us. We'll respond, email. Here's our contact information for each one of us. And certainly on the back of the guide, you've got phone numbers, addresses, everything. Elise, Corey, you two have been great. You've sheltered the heavy load on this one. I just keep the point to you guys. So thanks for your help. And again, you know, we had a lot of people help us put this guide together. And so MTC Solutions, American Wood Council, Woodworks, It takes a team, it takes an army, and we put this guide together as an industry, and we're proud of it, and we're glad that you joined us. Thank you. And we'll see you on the next seminar.